So this is the graph we were trying to draw. Let me show you what I've come up with. Now for the room temperature chocolate, I've just drawn a line like that. It took a bit more stress than to deform the nougat, but that stress was elastic until the chocolate broke. There was no plastic deformation at all with the chocolate. It's brittle. The caramel, on the other hand, though, at room temperature, took very little stress before it started to deform, and then we got a lot of plastic deformation before it too broke. So we now have, for our room temperature Mars bar, these three stress strain curves. If you haven't done so already, draw in what you think the frozen chocolate and the frozen caramel would be like. Would they take more stress to deform them? Would the stress be different from these examples I've given? This is what I thought. The frozen chocolate, you may have heard the amount of effort it took to break the bar in the video. It takes a lot more stress to break it. However, there's still no plastic deformation. It's still just a straight line. The frozen caramel, on the other hand, again took more stress before it deformed, and then we got a lot of plastic deformation. In fact, that didn't, in the end, break. Perhaps because I waited a little bit too long between taking it out of the freezer and actually deforming it. So this gives us some indication, perhaps, of how rocks behave at different temperatures. We think that rocks are all hard, cold, brittle materials, a bit like the frozen Mars bar. However, if the temperature is increased on those rocks, just as the temperature on the on the room temperature Mars bar was increased, we then see these materials behaving in a very different way. It may well explain why we have cold, hard, brittle rocks in this cliff that have bent and broken as a result of stress, that have folded and faulted. Those of you digging deeper now, can you now add more detail to your annotations? Can you explain the deformation in this cliff on the basis of these stress strain curves? So as the sun sets over Broadhaven, we can see now all the factors that have an effect on whether rocks show any deformation, whether rocks will bend or fold, or whether they'll break as a result of this stress and create what we call a fault. Next time we need to look at, in particular, this idea of faulting, how rocks break and the different ways in which they can break. But that's for another lesson. I'll see you then.